Okay, welcome back. This is Circles Volume 3. Today should be Thursday. Before we get started with a warm-up today, I quickly want to go over the two problems from yesterday's exit ticket with you. So if you still have your smartboard sheet, please take it out now. Number 1 says a baker has a circular cake pan that has a radius of 10 centimeters. What is the approximate area of the bottom of the cake pan? There's some really important information here that's going to make this problem easy to solve. First of all, it's circular. Second of all, it has a radius of 10 centimeters. So I'm going to draw that on my circle, a radius of 10. Just like all of these problems, one of the most important things that we need to know is the radius and diameter, because that is going to help us, God, I hate this smartboard, figure out what the circumference and area are. So, in this problem, it has a radius of 10, which means it has a diameter of 20. The problem asks us what is the approximate area of the bottom of the cake pan. So we want to know what the area is. Cake pan, circle on the bottom. We know what the radius is, 10. We know the diameter is double that, 20, and we want the area. So, again, you should have this formula memorized by now. Area of a circle is area equals pi times radius to the second power. Again, by writing the radius and diameter from the circle, it makes it so easy. The area is the same as pi times radius, which is 10 to the second power. On my calculator, all I need to do is pi times 10 to the second power, pi times 10 to the second power, and I get the area is 314.15, approximately 314 centimeters squared. Number 2. This problem is not tricky, but it just takes some effort. So in order to get this problem correct, you really needed to put in a little bit of work. This is not a problem that you can do in 1 or 2 minutes. It takes some time. Diameter of circle F is 5. Circle G has a diameter that's double that of circle F. So, circle F has a diameter of 5. D equals 5, which means the radius is 2.5. Circle G has a diameter that's double circle F. Well, if F's diameter is 5, this will be 10. So the diameter of circle G is 10, the radius is 5. That information is important. Now it says which statement is correct about circle G. And if you look in the answer choices have to do with circumference and radius. So let's take a look at these. Just by drawing the picture and labeling, we might be able to figure out our answer. So let's go to questions that ask about the radius. Answer choice C says the radius of circle G is the same as the radius of circle F. Well, we found the radius of circle G to be 5. The radius of circle F to be 2.5. Those are not the same. So we can eliminate answer choice C fairly simply. Answer choice D says the radius of circle G is half the radius of circle F. Well, the radius of G is 5. The radius of F is 2.5. That's not true. It's actually double the radius. So, just by simply marking what the radius and diameter are of each circle, we've already doubled our chances of getting this correct. Now, answer choice A and B both ask about the circumference of each circle. So to solve this, you would find the circumference of F, find the circumference of G, and you would determine that B is the correct answer. This problem is not difficult. However, it does take a little bit of time. Okay, moving forward. The warm-up for today is on the board. Please pause this tape and take 9 minutes or so to complete the warm-up. If you finish early, you can play the tape. If you need a little more time, take your time. Okay, you should have unpaused. Number 1, a student is determining who the favorite 7th grade teacher is. Which group should the student survey to collect the best data? Well, if we want to know who the favorite 7th grade teacher is, asking the principals and assistant principals, not going to be our best way to determine that. Asking all the teachers in the 7th grade, not going to be a good way to determine that. Asking 10 of the students' best friends, probably not. If they're best friends, they might all think the same. The best way to determine this is to take 10 random kids from each class. Because if you ask 10 random kids from Miss Musser, Mr. Smith, Miss McCullough, all the teachers on the team, and all the teachers on the other team, you will have a fair sample. Number 2 says solve the following inequality. This looks very similar. Oh, I have to move this board. This looks very similar to the problems we've been doing all week. It says 3 minus x is greater than 2. Again, our job is to isolate or get that variable, the x, by itself. In this problem, the first thing we have to do is get rid of this 3 by taking 3 away. We're left with negative x is greater than negative 1. If you didn't get negative 1, you probably didn't use your calculator. On your calculator, you should have typed in 2 minus 3. So, here we are. We're at negative x is greater than negative 1. We're not done yet. Our goal is to get the x isolated or by itself. Right here, we have negative 1x. So we are going to divide each side by negative 1 so that we are left with x. Anytime you divide by a negative, you have to flip the sign. So it becomes x is less than negative 1 divided by negative 1, which is 1. Answer choice A. Number 3, a circle has a circumference. That word sounds familiar. A circle has a circumference of 188 meters. What is the approximate radius of the circle? If you need to write that last problem down, go ahead and rewind the video. Okay, let's look at some stuff we know here. Circumference. Right away, I know we're talking about a circle. And since we're talking about circumference, I know circumference is 2 times the diameter, or, oops, I'm sorry, scratch that. I know circumference is pi times the diameter. Sorry about that. Circumference is pi times the diameter. So, circle has a circumference of 188. What is the approximate radius? That's what we're looking for, is the radius. I know the circumference is 188. I know that's the same as pi times the diameter. We want to find the diameter first. This is a one-step equation. I am going to divide each side by pi and determine that the diameter is 188 divided by pi, which is 59.84. So the diameter is 59.84. Pretty simple. The diameter is 59.84. If you chose B for this answer, shame on you. Because the question does not ask what the approximate diameter is. It asks what the approximate radius is. So if the diameter is 59.84, to find the radius, you divide that by 2, and it's approximately a 30. Number 4, at a gas station, the state of North Carolina charges a 3% tax. If a person fills up their tank and is charged $32.40, how much will it cost after the tax is included? Well, tax, unfortunately, is an additional price you have to pay, which means the price is going to increase. Originally, it cost $32.40, but you have to pay a tax. Oh, I finally got the smartboard to work, finally, of 3%, 0.03. This, ladies and gentlemen, that is 30%. That's not what we're looking for. This is 30%. That's not what we're looking for. A 3% tax is 0.03. On your calculator, the original price was $32.40 times 0.03. That gives us a tax of 0.97, a 97-cent tax. To find the total amount, you have your original price plus that tax. You should use a calculator to do this math. You should determine that the price with tax is $33.37. Guys, this is day 4 of these warm-ups. These should be easy for you now. We have done the same sort of problem every single day this week. Gotta have it down by now. Okay, today's question should be familiar to you, is what are the parts of a circle and how can they be used to solve problems? On the board and in front of you are 2 separate problems. One is an area problem, one is a circumference problem. Pause the tape and solve them both now. Okay, unpause. The question on the left. Pizza Hut is determining how much cheese to use in their stuffed crust pizza. If the radius of the pizza is 6 inches, how much cheese do they need? We're talking about the cheese in their stuffed crust pizza. Okay? The question on the right. Pizza is going to cover a new pizza completely with pepperoni. They're going to cover it. The radius of the pizza is 7 inches. How much of the pizza will be covered with pepperoni? Well, let's think about this. If we're trying to figure out how much they'll use in their crust, I don't know about you, but all the pizzas I've eaten, the crust is along the outside. The outside is circumference. Circumference equals pi times diameter. The radius of the pizza is 6. Okay? Again, I'm going to draw that. Radius is 6, means the diameter is 12. And I'll plug into my formula. In this problem, they're going to cover a pizza completely with pepperoni. Well, if they're covering it, that means they're going to put it in here. All of this is going to be covered with pepperoni. This is making me hungry already. So, we know that the radius is 7. Radius is 7, okay? If this is 7, the diameter must be double that, which is 14. And if we want to know how much it covers, that's area. Area formula. You guessed it. Area equals pi times radius to the 2nd power. I would simply plug that in. I would do, on my calculator, pi times 7 to the 2nd power, or pi times 49, because 7 times 7 is 49. All right, today we're going to do kind of the next step in working with circles and circumference and area. We are going to be finding the area of shaded regions. A few hints before we get started. One, you know we're going to be determining area of figures, and also you're going to have to really think here. You might have to find the area of a half circle, of multiple circles, of rectangles, of all different shapes. So we're going to look at this example together. It says, the South Carolina Gamecocks are replacing the flooring under the basketball goal. Use the figure below to calculate how much flooring is needed for the shaded region. Okay. Couple things to think about here. I know they're replacing the flooring. of this shaded region. So one thing I notice is that that shaded region is half of a circle. I also know that if they're replacing this flooring, they're going to replace all the inside of that. So they're talking about the area. And I know the area of a circle is pi times radius to the second power. Okay. So let's focus on this shaded region. And as we work through this, it's going to make a lot of sense for you to take notes and think about what's going on. This is going to be one of those problems where you might have to pause and replay the tape. Looking at this diagram, I see that all the way across here is 10. And what I know about a circle is if something touches the 2 points of it and passes through the middle, that's the diameter. So the diameter of that circle is 10, and the radius of that circle is 5. Okay, and I'm saying circle because obviously if we had the whole thing, it would be a full circle. So, here's what I'm thinking. I'm thinking that to find the area of a whole circle here, I would use a formula. Area equals pi times radius to the second power, or area equals pi times 5 to the second power. So I'm going to use my calculator and determine that now. So pi times 5 to the second power, that would give us an area of the whole circle of 78.53 if we had an entire circle. However, in this case, we don't have a whole circle, do we? We just have half of the circle. So to answer the problem, how much flooring is needed for the shaded region? Well, if this entire circle would have had an area of 78.53, and we only have half of a circle, I'm going to divide that 78.53 and divide it by 2. Letting me know that I'll need 39.26 square feet. Just to talk through this again, and please feel free to rewind if you need to. We were determining how much flooring would be needed for the shaded region. To the left, I put some information I noticed. Well, I had half of a circle. That's what's shaded. I also wrote the formula for the area of a circle. I thought to myself, okay, self. Here's my circle. The length across, the diameter is 10, which means the radius has to be 5. So if I found the area of an entire circle, it would be 78.53. However, the shaded region was half of a circle. So I found my area of the whole circle and divided it by 2. Okay. We'll move on. I'm going to model the first one, and then I'm going to have you try the next ones. So at the top of this slide, it says, find the area of the shaded region. Okay, let's go to work here. Problem 1. Here are things that I'm noticing. I'm noticing I have 2 shapes here. I'm noticing a rectangle. And I know the formula for the area of a rectangle is length times width. I also see a circle. I know the formula for the area of a circle is pi times radius to the second power. There's some information I need here. So all I want is the area of the shaded region. So here's what I'm thinking. If the entire rectangle were shaded, if all of this was shaded, the area would be length times width, 20 times 10, which is 200. So if the entire thing was shaded, the area would be 200. However, the whole thing is not shaded. I have this circular piece that is not shaded. So the entire area is 200. I have to take away whatever the area of that circle is. So I know the whole rectangle has an area of 200. I just want to know the shaded region. So I have the whole rectangle, which is 200, and then I got to take away the part that's not shaded. So I need to find the area of that circle. And looking at that circle, I see it has a diameter of 10. From top to bottom, through the middle is 10, which means it has a radius of half that, which is 5. To determine the area of that circle, I plug it in the formula. Area equals pi times radius to the second power. Let's figure that out. Pi times radius to the second power, 78.5. So the area of this circle is 78.53. So to find the area of the shaded piece, which is the whole rectangle minus this circle, will be 200 minus 78.53. 200 minus 78.53, which gives me about 121.47. If you need to watch this video again, and I suggest that you do, please rewind the video, take notes, watch it again. On your own, on the sheet in front of you, please pause the video and solve question 2, which is this, and question 3, which is this. All right, question 2. Again, we want to know the area of the shaded region, and the shaded region in this one is pretty small here. So here are some things I know. I know the area of this entire square is area equals length times width. That's easy enough. 8 times 8. So the area of the entire thing is 64. If I want the shaded region, I don't want the area of this. So I'm going to have to take the area of the whole figure, which is that square, and I'm going to have to take away the area of the circle. See, it looks tricky, but really it's not. All the information is there. So when I look at this circle, I already know from top to bottom measures 8, which means the diameter measures 8. If the diameter measures 8, radius is half that, radius measures 4. So to determine the area of that circle, the area is pi times radius to the second power. On my calculator, that's pretty simple. Pi times radius to the second power, and I get an area of the circle of 50.26. To determine the area of the shaded region, I take the area of the entire thing, the whole outside, minus that part. So I do 64, and I take away 50.26, and I get a shaded area of 13.74 square inches. And that makes sense. Makes sense. There's not that much of a shaded area here. So if the entire thing was shaded, it would be 64. I don't have very much shaded. 13 is a number that makes sense here. Number 3. If I'm determining the area of the shaded region here, well, again, I'm thinking to myself, okay, self, if the entire thing was shaded in, what would the area be? Well, the area would be length times width, which is 15 times 4. Even though I know this in my head, let me double check. Yeah, the area of the entire thing of this rectangle, the area of the whole rectangle is 60. But we just want the shaded region. So we're going to have to take away the part that's not shaded. And the part that's not shaded is minus half a circle. Pretty easy. Let's determine what the area of this circle would be. Well, I know the entire thing across would be 4, diameter of 4, radius of 2. So here's my little circle here. To find the area of that area would be pi times radius to the second power. So the area of, if this entire circle, if it was full, it would have an area of 12.56. But we only have half of a circle. So we're going to divide this number in half and get 6.28. Okay? To determine the area of the shaded region, we have the whole area, which is 60, minus that half of the circle, which we just found to be 6.28. So 60 minus 6.28 gives us 53.72 meters squared. The key to these problems is thinking about what you are doing. None of this math was very difficult. It's just a matter of thinking it through and taking your time. Okay. On your piece of paper are 4 problems. Problem 1, problem 2, problem 3, and problem 4. Your job is to determine the area of the shaded portions in this problem, and this problem. This is a little bit different and a little bit trickier, so you might want to do number 3 last. Couple hints. In problem 1, see how many circles there are. In problem 2, should be a pretty easy one. Find the area of the large circle, take away the area of the small circle. In problem 4, find the area of the large circle, take away the area of the square. Each side of the square measures 16. In problem 3, you're just going to need to work it out. Pause the tape, work them out now. In problem 1, if you weren't sure how to get started, let me give you a little bit of a hint just to make this easier for you. The diameter of each circle is 8. So this circle has a diameter of 8, a radius of 4. I figured that out because the entire thing from top to bottom is 32. There are 4 circles. 32 divided by 4 is 8. Okay. The exit ticket for today. The exit ticket for today is 2 questions. One of the questions is an area problem. One of the questions is a circumference problem. Take your time with these. These are going to be a little bit tricky. Thanks for watching.